Oh my gosh. Okay. All right, we're ready. Number 10. Number 10 looks a lot scarier than it actually is. Now, I know when you guys see this, you're probably like, oh my gosh, just skip it, right? But watch this. Watch if we just take it one step at a time, okay? Let's just look at this guy, and let's see if we can simplify just this. Okay, looking at log 10 to the third power. Okay, so do you guys know what the base is right now for this? Yeah, good, it's 10. So we don't know what it equals, but we put it, we set it equal to x currently, just so that we can start the equation. Okay, so do you see the log? Good. Put it in exponential form, dog. So that means 10 to the x equals this whole thing that's right here. Okay, so 10 to the something equals 10 to the third. Do you guys know what that something is? Good. So that means that this whole first term is going to be 3. Does that make sense? Okay. That's just that first term. Now we're going to look at the next one. Okay, piece by piece. All right. So this is the this is an e, and we're dealing with natural log. So something to remember with natural log. If you have the natural log of, say, 2, it looks like this. The base is going to be e. Okay? So the base is like this. So we can rewrite something that looks like this, where it's e to the x equals 2, right? E to the x equals 2. Okay. So another thing to remember with natural logs is that if you have the natural log of e, these things just kind of cancel out. And whatever the exponent is, let's say that the exponent up here is happy face. Okay? Whatever the exponent is up at the top, that's just what this thing, that's going to cancel, and then you're just going to be left with happy face. Okay? So, let's keep that in mind. So, when I'm looking at this, I'm just going to set it equal to x, just like so. And then, in order for me to bring down this exponent, I need to take the natural log of both sides. So, watch what happens here. I'm going to go natural log. Yeah, he's over there. Natural log of e to the natural log of 5, like this, okay? Now, on the other side, we have the natural log of x, okay? So, do you guys see how it says the natural log of e?
Yes.
Okay, so watch this. That cancels just like we just proved right here. And I'm left with natural log of 5 equals the natural log of x. So, do you guys know what x equals?
Natural log of
It would just be 5, right? So, since that's a plus sign, I'm just going to say 3 plus 5. Okay? So we're on the right track right now. All right, we should say something like video in progress. Okay, so this one right here. Now, when you're doing this last term, notice that it's subtraction, so we're going to be subtracting this. And then you guys could be, I bet you're thinking right now, you're like, hey, Mr. Wilson just said if I have natural log of e, that means it's just going to be the exponent, so that means that the exponent right now is 2, so then this is just 5 times 2, right, which is 10. Maybe you guys were thinking about that. Okay, you could do that way, or you could say whenever there's a number in front of a logarithm, I can put it up like this, and so it's going to be 2 times 5. So the natural log of e, that cancels, and you're left with 2 times 5, which is 10. So this is 8. That's negative 10. That's going to be negative 2. That's how you do that. Okay? Now, I think you guys should do the next one all by yourself. However, I think I should help you out with this portion right here. Okay, let me get rid of this weird thing. I thought that was, there it is. Okay, so this next one looks a little bit weird. Do you guys see how, like, what the heck is this, right? So if I'm trying to, oh, where did I put that thing? If I'm trying to do that thing, hold on, where'd you go? There we go. Okay, I've got it. All right, so if I'm trying to do this portion right here, I'm not looking at anything else. I just want to know what this is. So there's a shortcut, but I don't think you guys remember the shortcut. So we're going to have to do the long cut instead. So if I have 3 to the power of a logarithm like this, and then it's to the 12, see, we need this to be something. Okay, now is this a logarithm? Or is this exponential equation? Yeah, this is an exponent. Even though there's a logarithm in the exponent, this is in exponential form right now. Okay, so that means we need to take the log of both sides. So if you take the log of both sides, then you can take what's in the exponent and you can put it over here. So you have log with the base 3, 12 times log 3 equals log to the x. Okay, now I'm going to leave this one together, but see how this one has a base 10, this one has a base 10 as well. I'm going to divide both sides by log 3. Hold on. It'll all come together in a second. Log 3 12 equals log x divided by log 3. Okay, now this is called change-based formula. Okay, change-based formula should be on your review sheet, but basically it works like this. Whatever this big number is, you take the log of that number, put it up top. Whatever the base is, you take the log of that and put it on the bottom. So in looking at that, whatever's right here is going to be that. Okay, so what does x equal? Good, so for that one, just know that this whole thing, this is just going to equal 12. Now the shortcut is, if you have this and you have this and it's a log, it's just this. Okay? But that's not the answer for part B, okay? That's just part of the answer. That's the only thing that I think you would get a little bit confused on.
I don't even understand how you got that.
Okay, I'll help you out in a minute. Okay, let's look at number 11. Now if it says to expand, whenever you expand something, that means that it's got to get bigger, right? You're going to spread it out. So we're taking one single logarithm and we're creating multiple logarithms. Now, you can tell how many logarithms you're going to have based upon how many terms you have that are being either multiplied or divided, okay? So watch. This is being multiplied, this is being multiplied, this is being multiplied. So I have 1, 2, 3, 4 different terms. So that means I'm going to have 4 different logarithms, all with the same base of 10. So let's start it off. Log with the base 10, you don't have to write it though, 15. So that's going to be my first term. Since I've got a multiplication, do I put a plus, minus, what do I put here? Plus, good. So plus, and then I'm going to write log x cubed. But then, do you guys remember that's not simplified, that's not expanded all the way. How can I expand this? Yeah, good. We take this and move it to the front. Okay? So I really don't need that 3 there. All right, now we're going to look at the next since it's multiplication. So that's plus. Now log y, and then plus, see how we have the 5 right here? So that's going to be a 5 log z. Okay? Now that's expanded all the way. You can't go any further. Okay? Where's the next one? Oh, over here. All right, so part B is a little bit different as well because you guys see how you got, number 1, it's a natural log. Natural log and logarithms work the same exact way, okay? So no difference. And then since we have division, we know we have to subtract them. Now here's the deal with this one, okay? Because all of this stuff that's in the numerator is being divided by c, when you write this natural log of 25 plus, you know, the natural log of whatever, you know, all the things that are being added that are up top have to be in parentheses, and then you have to subtract it from the natural log of the c to the 4th, okay? So I don't want to give you the answer because I want you to try it. So give it a shot, and then just remember that this has to be in parentheses because it's all being divided by that, okay? All right, let's move along. Next one, this should be fresh in our minds because we just did conics, okay? So an ellipse, when it comes to an ellipse, we can either have a vertical ellipse or we can have a horizontal. How can we tell if we're going to have a vertical or what the heck? What do we do? Yeah, good. Okay. So if the bigger number is underneath the y, it's going to be like this. If the bigger number is underneath the x, then it's going to look like this. So there's no denominators right now. That means that this isn't in standard form. Also, it's not equal to 1. So how do we get this 36 equal to 1? Good. So divide everything by 36. So 9 goes into 36 4 times, so that's going to be x squared over 4 plus y squared, well, that's going to be 9 divided by 9 equals 1. All right, so from here, we can just rack up all these things right now, okay? So finding the center, we just look at what's with the x and the y, so that's going to be 0, 0. Okay, so I could plot that point. And then the vertices are on the major axis. Now, since the bigger number is underneath the y, we know that it's not going to be this one, right? It's going to be this one. So the bigger number, whatever's underneath the y, you take the square root of that, and that's going to be the distance in the y direction. So we go up 1, 2, 3. That's where one vertex is, and then go down 1, 2, 3. That's where the other one. Okay. So those are the 2 vertices. So I could say vertices are going to be at 0, 3, and 0, -3. So we'll just say plus or minus. Okay. Those are the vertices. Now what the heck, extra credit, let's do co-vertices. co-vertices is taking the square root since this is underneath the x, so that's going to be 2, and then 2 this way. And so then we could just draw our parabola, or not parabola, our ellipse. Okay, there's our ellipse. Co-vertices are at plus or minus 2, 0. All right, now the last thing it asks us for is foci. Foci, we get that formula by going a squared minus b squared equals c squared. So the a squared is 9, so 9 minus 4 equals our c squared, which is 5. 5 equals c squared, so the square root of 5 is going to be just our c, right? And c is the distance. So how far is square root of 5? What is it, like 2.3 or 2.2? I think it's 2.2. Okay, so that means from the center I'm going up 2.2, which is about right here. That's my foci. And then from the center I go down 2.2, which is about right here. So the foci is going to be at 0, plus or minus 2.2. Okay, that's the answer for that guy. And I think we found everything. All right, number 13, I would have you guys do by yourself, but it's kind of a tricky one, so I'm going to do it with you and for you, okay? So obviously this is a parabola, but we need to figure out, is this going to be a happy face, sad face parabola, or is this going to be a C, backward C parabola? Well, happy face, sad face is when it's y equals x squared, right? And then this one is when it's x equals y squared. So, I mean, you guys see the y squared? So that means it's going to be a C, okay? So that means that we know it's not going to look like this. And this is kind of like a different realm whenever you're doing the C one, okay? So I'll show you, but first I'm going to get the x by itself, kind of like what I'm used to. So I'm going to divide both sides by 8, okay? And then I'm going to subtract 2 from either side. And so my equation looks like this, where it's x is by itself, and then I have 1/8 is my a term, 1/8 y squared, and then I have minus 2. Okay. Now initially, the reason why this is kind of weird, because whenever I'm doing happy face, sad face realm, it's like when I have y equals x squared minus 2, I know something right away that this is going to be my y-intercept. Okay? That means when I go to graph it, I just have to go up 2, or I'm sorry, go down 2, and then put a dot right here. Right? But see, this is like completely different. It's flipped, or it's side flipped, I guess, okay? Because this number that's right on the n right here, this -2, is not a y-intercept, but that's my x-intercept. Okay? And then since my a term is positive, that means it's going to be opening up this way. Now I know that that's my vertex also because I'm a stud when it comes to these ones, and I know that when there's not a b term, wherever the y-intercept is, that's where my vertex is going to be for my parabola. Okay? So here, I know it's going to open up. I just want to know how it's going to open up. So I'm going to take my equation, and I'm going to choose a y value. Now remember how before how we choose an x value to substitute in and come up with a y? But now we need to go backwards. Okay, we're going to choose a y value to substitute in and get an x value. So since I have a fraction as my a term, I'm going to choose something that would cancel out. Okay, so I need to choose a number that when I square it, it'll divide out with this 8 and not give me a fraction. Because I don't want fractions. Okay, so watch this. I'm just going to go through some squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Well, any of these numbers like divide out with the 8 with a 4, 5 squared is 25. Right, 1's 16. Okay, so if I choose a y value of 4, 4 squared is 16. So 1/8 times 16. You guys see how that's going to cancel and give me a 2? So 8 goes into 16 2 times. Okay, but then I also have this minus 2, so I have to bring that down. So what's 2 minus 2? 0. So this is the ordered pair that I need to plot. Okay? So when x is 0 and y is 4, my parabola is going to open up like this. Okay? Since my parabola is opening up like this is my vertex. So that means that I can, I'm sorry, not my vertex. This is my axis of symmetry. So that means that I can reflect this point over the axis of symmetry. So I'm just going to go down 4. So 1, 2, 3, 4. Okay? Guys got that? Easy? Good.